6.4 Radian Measure of Angles. Your essential question, how can you express angle measures in radians? This is nothing new. It's just a nice review. For most of your life, you usually are using degrees to measure angles. That came from the Babylonians, who used a base 60 counting system. And so what they basically did was they took a circle and they divided it up into 360 units, which they then called degrees. That's not necessarily the most mathematically accurate way of measuring an angle. A better way is what we call a radian measure, and that basically compares the radius with arc length. So it's the question of, how many radiuses of a circle can I fit into a specific arc length? So by definition, we say that radian measure is basically equal to the arc length divided by the radius. So in the unit circle, which if you remember, in the unit circle, hopefully you remember radius is always going to be 1. So if I draw a radius of 1, and then I draw some angle, where this right here is the arc that is subtended by that angle, and I say, okay, I've got an angle of 1 radian. Well, the arc length, which we're wondering about, divided by the radius, is going to give us the radian measure, 1 radian. So that tells me then that my arc length must be 1 unit. Now, that can go on to any circle out there. So, for example, maybe I don't have the circle. I have some other circle. Maybe it's got a radius of 3. And let's say I cut off an arc with 27 units. And I'm wondering, well, what is this angle in radians? This angle in radians, I'm going to take those 27 units, which is my arc length, divide it by my radius, and I'm going to get a measure of 9 radians. So that's basically how radians, radius, and the arc length are all related to one another. Now again, if I'm talking about the unit circle, and I talk about an entire revolution around, well, what's the length of the arc subtended by an entire revolution around? Okay, well, that would be called the circumference, right? And we know that circumference is 2 pi times the radius. And in the unit circle, the radius is 1. So we know that an entire revolution around this circle is going to be 2 pi radians. So that leads us to, how do we convert between radians and degrees? So radian degree conversion. And I highly recommend that you use unit analysis to think about this. So we know that in degrees, 360 degrees is the same as 2 pi radians, which is the same thing as 180 degrees relates to pi radians. Now, usually we don't write radians here, okay? If you have an angle measure and it doesn't say degrees next to it, that means it's radian. But for unit analysis, it might be helpful to use the radians. All right, so, well, let's see. I'm just going to assume that you all know how to use dimensional analysis, so I'm not going to go more into that. We're just going to do a couple of examples, okay? However, on page 302, they talk about, to find the radian measures, this is what you do. To find the degree measures, this is what you do. But again, like I said, we're going to use just unit analysis. Okay, so example 1 is to convert 135 degrees to radians. So I've been given 135 degrees. Now I want to get rid of degrees. So that means I actually need to multiply by the reciprocal of this, right? Start with pi radians over 180 degrees. So now the degrees reduce out. Okay, I can divide 135 and 180 by a common factor. I end up with 3/4 pi radians, which is a more exact answer, or I could give it as an approximate answer, depending on what they ask you for, of 2.356 radians. I'll call them rads right there because I'm out of room. Okay, and then we'll do the other way, where we go from radians to degrees. So we're going to convert 5.73 radians to degrees. So now I'm starting with 5.73 radians. I want degrees, so 180 degrees goes in the numerator, which relates to pi radians in the denominator. The radians now reduce. And then if I were to multiply across and divide by pi, I'm going to get, oops, this is actually an approximation, of 328.305 degrees. Pretty simple stuff, right? Use your unit analysis. All right, example 3. We're going to find tan of 3.7. Now, tan of 3.7. 3.7 what? Well, they didn't tell you degrees. So you assume now that that's radians. So it's important then that you be in radian mode when you're calculating this. So I'm going to go to my mode. I'm going to make sure that I'm in radians. And then I can just type it in. So I want tan of 3.7, which leads me to approximately 0.625. Okay, let's do another example. Let's do example 4. We're going to find the radian measure and degree measure of an angle whose sine is 0.3. So in other words, sine of what angle is 0.3? Sine of what angle is 0.3? So this, in order to find this angle, what do I need to use? I need to use sine inverse, right? So sine inverse of 0.3 will give me what? Now, if I'm in radian mode, it's going to give me the angle in radian measure. If I'm in degree mode, it's going to give it to me in degrees. So sine inverse, I'm currently in radian mode, of 0.3 gives me about 0.305. I'll put approximately. And I'll write that it's in radians. But I'll also do that in degrees, the exact same thing. I'm just going to change my mode. And I get approximately 17.458 degrees. Excuse me. So you can see how you can get two different answers. They're talking about the same angle, though. All right, we have some special angles that we need to remember. And our next lesson, which we'll do in class together, is we're going to review the unit circle one more time. So let's talk about some of these special angles on your unit circle. Okay, so one of our special angles is a 30-degree angle. All right, so 30 degrees is actually what in radians? All right, so to get to radians, 30 degrees, I'm going to do pi radians over 180 degrees. And then if I reduce these, I get pi over 6. So that's a special angle in radians. How about 45 degrees? That's another one, right? So multiply that by pi radians over 180 degrees. And I end up with, once you reduce, you get pi over 4. Another important one is 60 degrees, which is actually 2 pi over 6's, right? So 60 degrees is the same thing as pi over 3, right? Because 2 pi over 6 reduces to pi over 3. 90 degrees, that's another special one, which is actually 2 45's, right? So 2 pi over 4 is going to be pi over 2. And then 180 degrees, well, as we talked about, 360 degrees is 2 pi. So half of 2 pi is going to be pi. And then 360 degrees, as we just said, was 2 pi. Okay, so those are some of the important ones, and we're going to be working with those a lot. Which brings us to example 5, our last example. Find the exact value of secant pi over 6. Well, secant is the same thing as 1 over cosine, right? So this is really 1 over cosine, and pi over 6 is the same thing as 30 degrees. So 1 over cosine of 30 degrees. So in order to do this, we need to know what cosine of 30 degrees is. So we're going to use our special right triangles. Unless you have these memorized, which hopefully tomorrow after we do the unit circle, you'll start to get these back to being memorized. Okay. So if I think about a 30, 60, 90 triangle, well, if I think of this as being the unit circle, then my hypotenuse is going to be 1. And on a 30, 60, 90, the hypotenuse is always equal to 2a. And then the side opposite the 30-degree angle is known as a. And then opposite the 60-degree angle is a root 3. So this means that a is going to be 1/2. And then a root 3 will be 1 over 2, actually 1 root 3 over 2. Or root 3 over 2, same thing. All right, so trying to find 1 over cosine. Okay, well, cosine is adjacent over hypotenuse. So we're going to have 1 over the adjacent is root 3 over 2 over 1, which basically is just 1 divided by root 3 over 2, or in other words, 2 root 3. If you wanted to rationalize that, then you'd have 2 root 3 over 3. Okay, your textbook's just going to leave it like this, and I'm fine with that.